That's it. Zoom owns you now. So, all right, let's have some fun. Let's go with the first question. So pH calculation, which definitely is part of the exam. Remember that. I'm going to give you some basics, right? So let me start you off with the right foot. Do not memorize. Whoops, that's not memorize. Memorize the formula. Why? Because that's what you're going to be doing in chem. That's what you're going to be doing in OChem and all that good stuff. I'm here to tell you that there's a far easier way to do that. So let me show you, right? So key things you want to do. Obviously, you want to know the table in terms of what it means, right? So the ranges are important to know. So make sure, again, you're going from 0 to about 7, right? That's going to be, let's see if we can put it there. It's going to be your acidic range, right? At 7, it's supposed to be your neutral range, right? And then anything above that from 7 to about 14, even though that's not the correct range that exists, but we'll go with it. That's supposed to be alkaline or basic. If I can spell it. I'm trying to do this from a distance. So let me just change this guy up really quick. Yeah, 7 to 14. Those are the main things. Now, the question is, how is that calculated? And so allow me to kind of give you a bigger trick that hopefully you'll use in both chemistry and, in OChem, because I assume most of you have taken Gen Chem. Let me see if I can change the layout of this slide really quick. There. So one thing that happens is, remember, the biggest reminder is, let me give you the formula if you want to know it. pH, for those of you who don't know what that means, it stands for the probability of hydrogen. And so you all get this kind of classic, it's the negative log, if I can spell that out too, which is base 10 of the concentration, the molar concentration of a certain substance, typically, in this case, hydrogen, right? And so if you decide to throw that number in, your calculator, that'll be nice and easy, but believe it or not, you don't need to do that. You don't ever need to do that. Allow me to show you why. So if you kind of look at it, remember, it's just a matter of counting tens. So what that means is a very simple example. Anytime you have a 0 in your number, in your concentration, you already can count what the pH is going to be. So allow me to kind of demonstrate. Let me give you kind of a really quick 3 different examples. There's that one. There's that one. And let's go a little crazy, right? And let's go way too many zeros for my comfort, right? There we go. So you're seeing that over there. And the idea behind it is, rather than trying to punch all this in your calculator, you already have the answer. This little thing that says log base 10, allow me to use my pen over there. Hang on, let's see if I can get this guy going. Let's try this again. I'll use this guy over here. I'll use my highlighter. So you know that there's going to be a change in sign, and you know that there's going to be things that are power of 10. So if you actually take that into account, it's actually quite easy. Just count the zeros, right? So I'm going to try and do this with each individual. So you have 1 0, 2 0, 3 0, 4, 5, and 6 zeros, right there. And then you always include that final position, right? So that last number that we have in there. So that's a grand total of 7 numbers. And that, literally, people, is pH 7. So you don't have to kind of think about it too much. That's what the number is. So you just have to calculate the amount of positions. Now we can try with the other one, right? Let's try this guy over here, right? So same thing, a little bit easier to count, right? You have 1 0, 2 zeros, and then another position. So this one, anybody want to tell me what that should be? pH? No, nobody. 3. That's about it. That's all. That's as easy as it gets, people. Okay, so let's give you the challenge then. Try the bottom one. See how crazy that is. While you guys are doing that, let me kind of answer a few things over here on the
15.
Is that how many zeros I throw in there, since I didn't count, believe it or not? So if there's 15 zeros, which there probably is, let's try this just really quick. We'll do it in 3.
Oh, Professor, I thought you said places, or do you mean only zeros?
No, it's places. You're absolutely right. I'm just counting them over here. 3, 3, 3. Yep, you're absolutely right. There's 15 places over there. And so that means technically it should be pH 15. Now, the range goes from 0 to 14, so I get it. I got overzealous with the zeros over there. But believe it or not, your pH actually goes up to 55 if you didn't know that. If you learn it from basic GChem or OChem, we find out that pH can go much higher than that. It's just that's the basic range that we talk about. Anyway, so everybody get how to do this number instead of having to use that silly little formula? Everybody good on that? Does that kind of help? So now, let me kind of add to this is what type of questions would I throw in the exam about this? This is kind of the level of what you'd see, right? I'll give you a number, right? Something like this. And as long as you can estimate those placeholders, basically, up until the last one beyond the 0, you're good to go. And so it'd be fairly simple. Now, I'm not going to ask you to do like really weird pHs either. That's just not fair. I'm not going to throw like a 7.235. Just, there's no point behind that. For our class, we just want to know a kind of a general range on how to calculate that number. And as long as you know the zeros and the last number, you should have at least a good idea what pH is. Okay, so don't go too crazy trying to figure it out. And again, you don't really need that formula unless you have that. Now, for those of you who are in possibly OChem doing this, there is a way to do the rest. So let's just say rather than just ending at 1, it ends up being like 1, 2, 3, 4, 5 or something like that. The numbers just start going in between those pHs. So instead of being 7 and 8, it becomes 7.1, 7.2, and so on and so forth. So for us, we're not going to really deal with that kind of accuracy per se. So I did see your hand, Khalil, so bring it on. Just remember, try and sing a little bit better since I might not see your screen. What's up?
Is alkaline also called basic?
Yeah, we can use both of them. So if you want over here, you want to use the alternative to alkaline, so I'll add it over here too. And there. We can call this also basic. It means the same thing for us. Not a problem. All right. So anybody having any trouble with the pH bit? Does that make sense? This is as ugly as it's going to get. So you can calculate these numbers that we're seeing over here, and then you can figure out the ranges that we have over here. You should be able to answer the questions on the exam. You get 2, 3 points out of that in no time. Does that help?
Yeah.
All right.
I have a quick question.
Bring it on, bring it on. So I'm trying to read the chat box too. So yes, but ask away, people.
I saw that the exam was 22 questions. Is that correct?
That is correct. So if you saw the instructions in there, which is the more important part, keep that in mind. It tells you that in order to kind of give you guys a little bit of a break, I wanted you guys to have a little bit of facility in terms of the first exam, which is just a basic introduction to the course, right? So it's a little bit of what microbiology is and a little bit about what, chemistry you should know before we move on to bigger and better stuff. So yes, and in reality, it's technically out of 20 questions. For those of you who might have forgotten, I always add this extra 10% little cushion in the background so you can have extra points in there. So even though there's 22 questions appearing there, there is, it's going to be out of 20. And this is why I don't trust Canvas usually to do the numbers, because it'll continue to calculate your score out of 22, when in reality, it's going to be out of 20. So keep that in mind.
Okay, thank you.
Yeah, no problem. Let's see. Trying to check some of the questions over here. Sifal, you asked the question, is one of the said draw the bonds. We're supposed to draw something because of challenges in drawing. Oh, well, I can give you that little bit. So let's kind of add. Let's add kind of a question in general over there. What do I mean by drawing in the exam, right? Well, you guys should consider yourselves lucky. This is kind of obviously going to be online via Canvas, right? So let me see this. Which means it doesn't really leave a lot of room to draw anything. So you're not going to be drawing in this particular exam or any of the exams, but what you will be doing is identifying more than anything else. Your ability to identify things like bonds, for example, is going to be a key feature. So no, we would spend too much time trying to have people draw on their phones, on tablets, or something silly like that. And especially if you're trying to draw on a tiny little screen, it might not come out correctly. No, we're not going to get into that type of issue. We want you to be able to know what these bonds are and how to identify them. So more often than not, what I mean by identifying is you're going to have anything like selecting something on the screen, or it's going to be circling something, or anything of that sort, right? So here, let me give you to the next screen. If this thing listens to me. There it goes. So that's kind of the level of contribution that you're going to have to the exam itself. I can't have you interacting with the exam too much because then it gets a little messy, especially for the graders, right? Or the system itself. So more or less when I'm asking you to do the doodles that we have in the lecture and in the lab and that kind of thing, it's more or less you're going to be interacting with the screen and just saying, oh, that's the thing, or let me click on this portion or something of that sort. So keep that in mind. All right. What else, people? This is good stuff. This is good stuff. Bring something on. Since apparently chemistry was the bane of everybody's existence, it's cool. Ask me some questions. Here, I'm going to create a new blank screen just in case. Anybody? Anybody?
Do you want us to memorize the functional groups?
Yes, you should know your functional groups, right? So let me kind of add to that one. If this thing moves, there you go. So in terms of your functional groups, right? The idea here is you should be able to, again, same concept, you should be able to identify them. And what I mean by this, again, you're not drawing, even though good practice probably if you're kind of doodling them on a piece of paper so you can get used to for them, it's pretty easy. So, but you're not going to draw them, but it's the same thing that I did in the previous slide is definitely selecting them somehow from some sort of image. So I will provide you with something and you should be able to find it. So let's try that just for like half a second again in the spirit of what we're doing in the exam. So let me change the organization here. Now I have no idea what I'm going to insert here, so I have to kind of do a little bit of cheating and find a compound over here that I can throw on the screen. So let's try this. I'm just doing a flat out Google search on something and let's see what I can find so I can steal over there. Nope, that just gave me a bunch of little doodles. There we go. Let's see what fun stuff we can find over here. Of course, everybody gives me all the basics. Here, let's steal this awesome image. Copy image. Bam, there. So I don't know where I stole it from, so don't judge me. So you have some sort of compound put up there, right? And so I will ask you, hey, identify, some sort of functional group. And not that many of these are very, very difficult to do so, but at least the ones we're covering in the lecture, in the image that I provided in the exam, you'd have to find them. So let me give you some pretty basic ones, right? So let me just switch to my selector over here. I'm gonna use my highlighter. If this works, there it goes. Let's go to highlighter. And so probably the easiest one to always tell, even though it's already highlighted in red, here's a little hydroxyl group that you could be highlighting or selecting on the screen. That would be what you would do. You wouldn't be drawing it. There's definitely a couple of ketone bodies over here that we can throw. For example, that guy and this guy. This is very difficult to do with a mouse right now, right? And if you really wanted to get fancy, for example, this is a methyl group just kind of sticking out, right? That's kind of the level of interaction you'd have with the screen in the exam. So drawing them does help. I encourage you to doodle them going along, but I will be the one that provides you with the image that I want you to work on and just interact with it to select what you need from there. Okay? Does that help people? Does that make sense?
Yeah, thank you.
Remember, I live for your thumbs.
Professor, is the one with the dashed lines, is that an amino group?
Are you talking about this one over here? I assume you could see my highlighter, but is that what you're talking about?
Yeah.
Unfortunately, because this is, what do you call that, a delocalized electron over here going on into this weird kind of benzene-ish kind of string, it doesn't count. So any of these guys kind of sticking out are not quite amino groups. So amines usually have to stick out on their own bond and have their own little hydrogens hanging out. So technically it doesn't count. It is nitrogen-based, but that's as good as it gets. Now, I just stole this online, so trust me, my pictures are not going to be this crazy. So you're not going to have that confusion of, oh, I'm not sure if it is. Mine will be obvious. Trust me on this. Okay? I don't want to torture you. I just want to make sure you have the material.
And the OH, is that the alcohol group?
That would be alcohol or technically hydroxyl group. Either one of those is correct.
Okay.
Anything else? Anything else? Bring it on, peeps. This is fun.
Yes, I have a question.
Yep. Bring it on.
I remember in the lecture you said somewhere that all elements are neutral. However, or is there some elements are more less neutral, like they're more ionic, like the alkalines? That's why I was having confusion.
Okay, so I'm going to see if I can try and address this because there's a little bit more information in there. So let's talk about elements really quick. So stuff that you should be knowing for the exam. One of the key things that when I at least am talking about my exam, I'm talking about neutral elements. What I mean by that is that there's no charges or no ionization. So anytime I'm talking about any element in general, unless I tell you something specific about it, I mean just a good old element, sticking it from the periodic chart, periodic table, and that's about it. Nothing fancy, so don't go too crazy on that. That's what I mean by that, okay? So let's see, hang on, let me make sure. Oops, need to take care of that, there we go. So that's part one. Now, make sure you understand their properties. And by this, the standard definition of your element should be something that is can no longer be divided into something smaller through some sort of physical or chemical mean. So this is any type of substance, basically. You can't break down that easily. That's pretty much what I'm trying to say there. So let me add a little bit to that substance. Okay. And so that means also that it has consistent properties or constant. So as long as it's the same substance, as long as technically it's the same element, it should behave the same way, no matter what. So that's the basics behind that element, right? Now, as far as we go, because I'm trying to make sure I address your question, Khalil. Let's see if we can throw this over here. Let me add that over there. Is that that means that the properties that you want to know are based on the periodic table. And so what that really means is that I need you to know, at least based on a periodic table, that you have access to it at home. It's not like you need to memorize this, right? Is you need to make sure you know its atomic number. Okay. You need to know its symbol, name, and atomic weight. And I do this because I want to make sure they reiterate that this is based on this neutral element. So I'm going to draw my little arrow over here for half a second. Although this is not going to help because it's going to change. Hang on, let me change the structure of this. A little bit easier. Okay, I just wanted to move things around so I can draw more examples. So let me do my little pen. So what I mean by that is that neutral element deals with these guys. All right, so it's important to know. Now, that means that, let me give you some examples over here. You guys can use your own periodic tables at home if you want to. I'm just kind of mess around with what I have over here. Let's go very, very basic because it's kind of easy to do the math on this. Okay, so if you go with something like hydrogen, right, most basic level we can get, you'd have to tell me its number. So I'm going to write it as this, right? I need to know its symbol. I'm going to write that. I said name, and then I said weight. All right. And so you looking at your periodic table, you see the giant number 1 typically in the top, or somewhere on the top of the actual periodic table. You know that it has a 1 right there, right? We already know, I'm sure everybody's sick and tired of seeing hydrogen for some reason. And then obviously we're not even going to contest the name unless you want to rename it into something funny. And then you get to find out that its weight, it's 1.018, okay? So that's what it is. Now, for us, even though that's the information you want to be able to identify in a periodic table, there's a couple of extra things we don't need. For example, the key feature here, and I'm going to change it in a moment, is that we don't really look at the atomic weights in that detail because 1, it's way too much stuff. But 2, just do the highlighter, we just kind of round it up. So it's always easy to kind of round this number out to something that makes sense. Since again, we're not going to be trying to be hardcore chemists, we just want to understand the general chemistry. So for us, that means it's just a weight of 1. Okay, that's really where we want to be. Okay, and so you always round to the closest integer. So let me add that in there. So if it was like 25.321 or something like that, it's just 25. Okay, you don't really need to know that much detail. And again, since you're going to have a periodic table available to you, you could just look it up and just round. Okay, so the rule is fairly simple. Anything up until like that 0.4999999 whatever, that goes down. And if it's 0.5 and above, you just go up. Okay, so you'll never have to contest it because we don't have exact numbers in there either. So that's basically what we want to know there, but there's a little bit more to that story. The reason why we emphasize that whole neutral thing is because we want to be able to calculate all its components. And by that I mean its subatomic particles. What does that mean? I'm asking you to tell me how many protons, neutrons, and electrons does something have. That's what we're going for. And we can only do this accurately, at least, if we use a neutral element. If we're starting to use something like an ion or something like that, it starts messing up the system, right? So we're, again, assuming that we're looking at neutral elements. And since we're playing with hydrogen, just for the moment, we'll go with it. Remember that the number of protons is basically equal to the atomic number, right? Which then that means, since we already know that the atomic number of hydrogen is 1, then we know that the number of protons for this guy is also 1. Right? That's how many protons hydrogen has. Very, very basic. Now then the question is, how many neutrons does it have? A little question mark over there, right? And so the idea behind that, now that becomes a little bit trickier. And so for that, I want you to start always using a rule of thumb that we have in there. So let me kind of insert a little box. So yes, I'm looking all weird over here. I'll throw it over here in the corner. Bam. Okay, you see my little box appear over there. And so let me edit the text. I call these rule of thumb. All right. The rule of thumb is actually kind of simple. The number of protons will always equal to the number of electrons. And it should approximate, notice that I'm using a slightly different symbol over there, okay, the number of neutrons. It's never quite exactly the same, but it's fairly close. So it should be closest to that number. So that's our little rule of thumb, okay? So to answer these questions, we already know that the atomic number of hydrogen is 1, right? It's right there. So then easy, should be able to tell us how many electrons does that guy have in a neutral condition. So that means that the electrons in there should be also 1. Not sure why I corrected it to a caps, so let me bring it back down. There it goes. And then the neutrons, so again, the rule is simple. It should be roughly the same. And so it just so happens that we can do that based on the atomic weight. And so how we do that is a simple little formula too. So let me put a little semicolon there. By using the atomic weight and then subtracting the atomic number, in this case, or the number of protons if you want to put it, I'm just going to put a little p over there too. That should give us the number of neutrons. And so that's pretty basic. We already know that the atomic weight of this bad boy is about 1. And we know that the atomic number of it is also 1. So if we do 1 minus 1, should be fairly easy to do that number, right? And so that means that this guy in particular has 0 neutrons. So in this case, 0. So we can try this, and so let's start kind of messing around with this system. So I want you to get some good practice over there. So let's start picking other numbers. So let's start, sorry, not numbers. Let's start picking other elements really quick so you can do the same thing. And so let's make it a little bit more of a challenge. Hydrogen is clearly a little bit easy, right? So if you have your lab notebook next to you, or possibly your textbook, right? Find your periodic table, because we're gonna mess with it just so you can do that too. So I'll give you like 5 seconds to get that done. All right, I think that was long enough, 5 seconds. So let's try it out. You should have some sort of periodic table close to you, hopefully. If not, Google one. Should be relatively easy too. All right, so let's give you some challenge here. So I'm gonna make you do math. Obviously, it's part of the exam too, right? So let's start with something a little bit lower on the scale. Let's use something that's fairly easy to work with. Let's work with the element nitrogen, right? So if you look at your periodic table on the top right-hand side, you should find the letter N, right? So look at the atomic number. Anybody want to tell me what the atomic number of nitrogen is? Work with me.
7.
7, right? So look at somewhere in the top corner of it. You see that its atomic number is 7. So the answer to that should be simple. Number of protons in nitrogen is 7. Pretty straightforward, right? Now look at the bottom of that symbol, right? So we know it's nitrogen, so we don't need to ask, right? What's the number that you see? Notice that it's not a perfect number. It gets all crazy, right? So you should be seeing something that is like 14.0067 or something like that, 0.07 of that sort. So again, we practice the rule that we've told you, we round. So we don't want to have that much, I'm not trying to mute you guys, just in case. Instead of calling it 14.00 whatever, just round it. Its closest integer is just 14, right? So we already have the formula for this. This is the same one that I have down here. Let me highlight it on the screen. If I can find my highlighter over here. Let's change it up a little bit. Let's go with green. This is our formula. This tells us the amount of neutrons. That guy. So we know its atomic weight is 14 because we rounded. We know its atomic number is 7, since that's the number that tells us on the top of the little square. So 14 minus 7 gives us, magic number, anybody? Should be difficult? No?
7.
7, right? It's that simplistic. So that means that for nitrogen, it just happens to have 7 neutrons. So it has 7 protons and it has 7 neutrons. And did I not tell you that that rule of thumb that I have up there is it's going to be roughly always the same number? So let me kind of expand upon this guy, since I think it's kind of important to know. Hang on. Make this guy bigger. Not the square. I need a bigger number. There. To emphasize that. Right? So, little kind of easy practice there. Now let's give you a good challenge. Let's make it kind of make you work for it. So, I assume that you're not memorizing the entire periodic table, at least not yet, unless you decide to be a weirdo like me and go into biochemistry. Let's go with something like tungsten, right? So for those of you who don't know what tungsten is, aside from going into your light bulbs and being some really good igniter kind of stuff, right? The symbol is W. Don't ask why the symbol is that way. So anybody want to find what its atomic number is for tungsten?
74.
74.
There we go, right. So again, look for it somewhere in the middle of the table where we have our transition metals. It's on the lanthanide series level. So it's 74. Good, I'm glad you found it. That's kind of the level of interaction that I need you guys to be finding stuff. So 74. So now what is its atomic number? Sorry.
What, 184?
So if you look at it, it says 183.84, which means we're rounding. You already said it, so I'm not trying to kill your awesome interaction. It is 184. That's it. You rounded to the correct number. Okay? So tungsten has an atomic weight of 184. We have that its atomic number is 74, so we know that it has 74 protons, which means we also know that it has 74 electrons. And now let's do some arithmetic. 184, subtract 74 from it. Anybody?
110.
110.
110. So we know that the neutrons are about 110. Done. You have all the properties of your element that you need to do, right? And again, going back to that rule of thumb, it's approximate. It's never this isn't always perfectly the same. It works really well at the bottom of the at the top of the periodic table. It works really well. As you start going towards the bottom, those numbers start getting really, really big and apart. So this is why I use the term approximately. Okay. So that's the level of interaction I want you to have with the periodic table, as well as your calculations. And again, a neutral element. Because if we start messing with ions, which we do for other reasons, those numbers don't work anymore. They have to be shifted a little bit. But I can give you a quick preview if you want to. Somebody go and hang out with, sodium is one of our favorite ones we get to play, especially in AMP, right? So if you look for sodium, which its symbol is Na on your third row over there, Na stands for natrium, which is its Latin name. You see that its atomic number is 11, right? And you see that its weight, if you round it up correctly, it should be about 23. So 23 minus 11 should be fairly easy, right? 12. So our 12 neutrons should work. Now, the reason why I picked that guy is because sodium forms ions all the friggin' time, and you always end up seeing a symbol like Na+, for example. Well, that means it's lost an electron, right? We already know that from GChem. So that means that when you did this math that I'm trying to show you here, it wouldn't be the same number of electrons and the same number of protons. There's one missing, obviously, hence why it's an ion. So what would happen is for that particular element in an ionic state, it would be, well, it has 11 protons, but it has 10 electrons instead. You have to subtract that one in an ionic state. But that's really where you're getting really too far into what I'm going to ask you in the exam itself. It's not that complex. Okay? So does that kind of help everybody? Does everybody kind of remember this, at least from good old GChem days and everything? So what else can I help with this, people? Julio, what's up?
Oh, sorry, I wanted to ask. So you're saying that even though sodium, as in the periodic table, it's still considered a neutral element, even though it's got more charge?
Correct. In the periodic table, this is where I'm taking it out. I'm stealing it directly from the periodic tables that you guys use. And so you should be able to have access to your own at home, is you're going to use it as its neutral state. Now, you're right. In real life, it's hanging out like an ion 99% of the time. And so is chloride, and so is fluoride, and all these various different versions. That's just too much trouble for me, honestly. And I don't want to kind of trick you into questions in this case, right? So treat all the elements in there as neutral, like I said. Hence, that's the important part to emphasize that word. Okay. All right. Hopefully that helps a little bit more. So what else, people? Talk to me. This is good chem. It's been like 75 years since I've seen it, so it's cool.
Hi.
So what's up?
I wanted to talk about one of the topics in topic A. It says,
Oh, okay, bring it on.
list the main characteristics of each type of class microorganism that is potentially pathogenic. So there's cocci, bacilli, and others. And then in the book, it talks about like MRSA and how it can be on the skin, but then if there's a scrape and it gets in it, then it becomes pathogenic. So for defining like each one, how do I know which ones would go to each class? Do I need to just dig through the book?
It's a fun question, and the answer to that, let me bring this so that everybody can hear me along over here. Let me shift the slide. Hang on. I lost my slides. There they are. Okay, so based on that question, so let's kind of shift it over here first. There we go. And what I mean by this, in case it might have added a little bit to confusion, is in terms of its pathogenicity, clearly, I assume you're taking this class because you're about to learn most of this stuff as we go along, especially when we do classification. That's really the kind of the nitty-gritty of that stuff. You'll learn that then. For right now, what topic A was really going after is for you to kind of understand the basics of what type of organisms we're going to be seeing. In other words, so let me add that to the screen, that way you can follow along. So in reality, what I'm telling you is examples of types, whoops, I didn't do that correctly, of pathogens. And so, yes, it's quite possible you can pick something from the book. And so I'm asking you to memorize the entire book, the last 5 chapters, so you can present it to me for exam 1. I'm not going to do that, people. That's just silly. What I'm asking you to do is the types. And so in the list of lecture 1, or topic A, if you recall, when you go through it, there's a little section that say, hey, these are the ones we're going to be covering in microbiology. So covering in our course. So in there, then I kind of categorize them, hence why I use the word type. I don't use classification in there. I mentioned, look, we're definitely going to look at bacteria. There it goes, right? And so I provide a couple of little examples in there, right? We're definitely going to talk about archaea, which don't happen to be pathogenic to this state. But we're going to look at things like viruses, parasites, protozoa, fungi, things like that. And that's really what I was talking about. What do I mean by the types? Okay, so as long as you can know that these are the ones we're going to be handling in the class, we're set most of the time. And then what I wanted to get is the other piece over there, which are some of the examples. Could you tell me an example of them, right? And yes, you could search through the book. Again, that's not the type of question I'm going to ask. But the idea is, could you tell me something that exists? And now, Christy, you brought up an example, so let me use the one you brought up. So let's go with MRSA, right? Just so happens that Staphylococcus aureus has this evil version, which is methicillin resistant, hence that MR part, right? So that is an example of it. And so let's go kind of a little doomsaying for today. We can go with our little viruses, but you know, there's clearly one going on right now. Let's kind of throw that off to the side, right? Let's go with something like a human herpes virus, right? Something like that, an HHV, right? So that's an example. That's as deep and dark as it gets. And I give you a couple of my examples in the recorded lecture. And then what I'm also asking behind that, and which was part of that, is, let me just, properties. That's probably the kicker of those questions. So what I'm asking about that are just generalized material. So we know, for example, that all bacteria are prokaryotes, meaning they don't have a nucleus. And bam, there you go. You have your one property that you needed to mention for the exam, right? And that's as ugly as it's gonna get, right? So let's look at a couple of other ones. Let's just kind of have some fun. Let's go with the fungi over here. And so these ones happen to be eukaryotic. I can spell it. So they do have a nucleus. I'm gonna put plus nucleus, right? But we can talk about other characteristics behind them. So this is gonna be a fun one that everybody should know, regardless. We're gonna test this throughout the entire semester, I promise, is that they do have a cell wall, for example. It just so happens that fungi do also as well. So they also have a cell wall. But if you were to look at some of the parasites that we're going to look at, for example, let's go with some protists. Let's go here. So these guys are going to be eukaryotic also, very similar to the fungi in that case. But, oops, in this case, they don't have a cell wall, so no wall, for example, for them. So that's the properties that I'm asking about. So there's a little bit of some examples and some of the generalized properties about them. Why? Because in topic F, once we really get into classification, you're going to learn exquisite detail of every single one of those guys. So that comes later. Right now, remember, it's just the intro. Just want you to know some basic material behind it. That's it. Okay, so if you can give me one or two properties about the guys we're going to cover in class, you're good to go. Okay, that's as ugly as it's going to get. Does that help, Chrissy? Does that answer that question there too? Cool. Everybody else is okay with that?
Yeah, absolutely.
Cool. That works. All right. What else? What else? What else? These are good questions, people.
Professor,
What's up?
would we need to know like what each microbiologist contributed to the microbiology, or like?
That question is a half and half. So I know where you're going, Sean. So give me half a second. Let me change the slide really quick. That way I can answer that in detail and save it. Hang on. Whoops, I forgot that you guys don't get to see the slides unless I change them too. Bam, there we go. So excellent question to ask there, Sean. Contributions. So now, if you listen to my craziness in the recording, right, you'll hear me emphasize this like tons of times. I'm a huge, huge, huge hater of history, right? Not that I hate the subject, that's not what I mean. It's that I hate memorizing dates, times, and names. It's just dumb. Unfortunately, I'm being recorded, so this may not work in my favor. But for us, at least, there's no names, no dates. Okay? I will never ask you that, promise. Okay? So that's not something you need to know. But, like I said, this answer is 50-50, right? You do need to know the contribution. So obviously the title of the slide, but meaning the impact to science or medicine. And so what I mean by that is, no, I'm not going to ask you what exactly did Louis Pasteur do, or in this case, Francesco Redi or something like that. No, I'm not asking you to give me that. What I'm asking you to do is what event took place. So what are examples? So you're not allowed to steal my one for right now, since I'm using it. Right? Key contributions, for example, this was the invention of the microscope, for example. Right? That is a significant change to our understanding of science and medicine, right? Now, about that, what I mean by this, and this is what I'm trying to exemplify, that's as much as I want you to contribute. That's it. That's a key event. That's a big deal. I don't need to know the name. You don't need to tell me, who are the fathers of the microscope kind of thing, and nothing like that. I might use those in the exam as kind of telling you a little bit of a story, just to kind of add a little bit into it. But no, you do not need to know any names or dates or anything like that. Like I said, I want you to know the concept, not the actual dates or names or anything like that. You can look that up. That's a Google question, so no, you don't need to do that. Let's see. One that I can kind of expand over here too. Another big example is the concept of cell theory. So, right. So in this case, again, you don't need to talk about the two main people that started it off or the three that ended up kind of claiming it as their contribution. It's more or less that was a significant event for us 200 to 400 years back, knowing that all cells were made from cells. That's the key contribution, nothing else. That's what I want you to know. So you should know, at least for topic A, what those key contributions are, okay? So does that kind of help with this out, the kind of answer your question, Sean?
Yeah, thank you.
Not a problem. Okay, so the question over here, let's go with something very similar, mind you. We'll piggyback off of that one. Let me just shift the slide over here. Whoops, I ran out of slides. Hang on. Let's make some more slides, people. There we go. So move to the next one. Bam. So another very, very similar question is the EIDs. And so very, very late in topic A, we talk about what we call emerging infectious diseases, right? And so part of the SLOs that I asked you to be familiar with, right, was this idea that you should be familiar with why, micro is important. And part of that is understanding that there's lots of things that are popping up right now that are of medical concern, right? And so in there, I gave you a bunch of examples. There's tons more, clearly. I just wanted to give you a few of them to be familiar with, right? And so what I'm asking about that, asking you about that in terms of it, is to be able to kind of identify and describe some of them. And notice that I'm going to add this to the slide, some of them. I'm not asking you to memorize any of these guys. It's pick some sort of topic of interest that you can say, hey, look, this is one of the EIDs. Guess what? Today, it just happens to be, a type of beta coronavirus that is killing us. That is an emerging infectious disease that is popping out, right? But there's tons more. And so at the end of topic A, I give you several of those. For example, let's try this over here. One of the examples that I gave you was E. coli. There is this one little interesting fun example called O157H7 E. coli, which has been the target of lots and lots of fun research because it's a very interesting version of E. coli. Notice that I'm italicizing it and underlining it. That's one of those properties you want to know, right? But this guy just pops up 2-3 times per year everywhere in the world, causing massive little outbreaks of diarrhea everywhere, typically at like McDonald's kind of level of food. And so that is part of this part of these examples of EIDs. And there's tons more of them. You'll notice that, for example, at the end of topic A, I gave you a couple of other different variations behind a couple of the latest viruses that are popping up. And anywhere in there was Zika and Chikungunya and things like these types of viruses are these EIDs. And that's it. What I want you to know is to hopefully be familiar with some of the current stuff that we're dealing right now. I don't want something that happened 800 years ago. That's no fun right now. I want you to just be able to tell me that, look, I'm familiar with the field of microbiology. I'm familiar with the fact that lots of things are out there trying to kill us as well. And here's an example. And I wrote one of them up there. You can come up with tons more. I gave you a few of them in topic A. Lots more out there, clearly. I just wanted you to kind of know why, again, it's important to study microbiology. There's good stuff about it. And then at the end, there's some of the bad stuff about it too. So I want you to be able to tell me about both. Good things about studying microbiology and scary stuff about studying microbiology. That's what we are trying to cover there. Does that help everybody?
Yes, Professor, I have a comment.
Yeah, bring it on.
Oh, I thought it was really cool in the lecture how you recorded that in around February, and you were saying how COVID-19 was going to be something very serious coming up.
Yes.
And it happened in February.
Well, believe it or not, I can't remember because I recorded that, beforehand. I always give the example. This is what doesn't happen when those are recorded. Is probably my favorite ones of them is the Chikungunya virus. And the reason behind it is because I happen to be a tropical baby. And so I travel to Mexico all the time. And the one thing that I always get killed with is mosquitoes. And so it just so happens that one of my trips on there, I got infected with chikungunya. And I can't begin to tell you how much I wanted to cry, just not moving in my little hammock and just crying myself to sleep because it was so painful on my bones and joints. So yes, you got the little fever that most of the time you get from these infections, but what happens is about 2 weeks later, after that, it didn't go away. I actually ended up having damage to my joints for about 2 years after that, simply because of that infection. I'm perfectly fine, trust me, I'm moving around like a dork right now. But that's one of the reasons why I remember it. It's simply because it happened to me, right? And so to be able to just say, look, I have things that I like to talk about is because I witnessed it, it happened to me. And so it happens to be still an emerging infectious disease. It's still spreading out, especially in tropical areas. So anything roughly in those wonderful places that we all like to go to hang out by the beach, you're gonna find this guy. And so whether it's gonna be a version of chikungunya, a version of Zika, a version of the dengue fever, or even something as far as malaria can go much later on in Africa, for example, same idea. Crazy mosquitoes trying to eat us alive, definitely still part of our world and definitely part of the current emerging infectious diseases examples. So I'm sure you have some, everybody probably does. Something got sick of something being bitten, touched, scratched, or whatever it is. So it's always good to know what these are. I just gave you some of them that I had in there. And I didn't try and sound like a doomsayer when I was talking about COVID-19 at that point in time. But for those of us that work in the field, we know how this works. And since we already had seen this plenty of times before, we knew what to expect. So,
Mosquito repellent doesn't always work.
I know, I'm just seeing the same comment over here. And trust me, I was like setting myself on fire, doing a little dance and everything else, and it still didn't work for me. So I grew up in Mexico. I'm from there. And so we have all these weird little kind of home remedies. And I tried every single one thing out there and it didn't do jack. So that's why I don't trust home remedies. Anyway. Anyway, so let's differ from that and crazy stories about Chris. So what else do we have, people? This is your time. I'm trying to help. Anybody else? Anything unclear? Is at least the review guide at least helping somewhat? One of the biggest things that I always am concerned because I get kind of a little bit of both sides. People are like, "Oh, I didn't use it." I'm like, "Well, that's your problem." But I want to make sure that you're getting the information from that is valid, right? So if reading those questions are helping you, then good. I need to know those so that I can modify them. If there's a question on the review guide that it just doesn't make any sense, or flat out reading that guide doesn't help you, then tell me so I can modify it and make it better. The last thing I want from you guys is for somebody to go, "That was just a piece of crap and I never used it." There's no point behind that. So why should I even post them? So I want to make sure you are using that and it's helping you. So that's the important part for me. Okay. All right. So good. At least appreciate those comments from you guys. Teresa, looks like carbon bonds you're asking there. So there's 2 questions. Do you want to expand upon it a little bit more? You can type it if you can't talk at that time. What else do you want me to talk about in terms of chemistry? I'm going to switch slides over here.
What kinds of questions will you ask about bonds,
Okay.
organic chemistry?
Sure, let's do that. Let's talk about some chemistry. Again, we keep on going back and forth. This is fun. So let's talk about bonds. So I'm going to make a quick list. That way you guys can follow along with this guy, and we'll go from there. So let's go with first definition, right? It's always important to know definitions. And so what I mean by that, in this case, I'm just going to summarize it. You shouldn't be using this version of it. It's, your forces that keep your elements or other substances together, right? And so you need to know the types that at least I covered in my lecture. Oops, not typed, types, right? And so that means your basic ionic, covalent, and hydrogen. Those are the ones that I wanted to talk about because those are the ones important for us, right? So you should know those, and you should know what each kind does, right? So for your ionic ones, in this case, this is the exchange of electrons. Which lead to charges. So electricity. So this is what you guys heard in topic B, as I call them, called electrolytes. Right? So those are the contributors to that. So let me actually add it below here. So that means that the ionic bonds, so bonds results from the attraction.
Negative and positive charge.
Absolutely right. Attraction of opposite charges. Exactly said. Oops. Harder to type this while I'm trying to speak, so hang in there for me. So that's what the ionic ones, right? So these are your ions, which is not the same thing as ionic bond. So keep that in mind. Be very careful. There's a difference between what an ion is and what a bond is, okay? The bond is that attraction that I'm talking about over here. Now, your covalent ones, in this case, I'm going to erase that little arrow for no reason. Give me 1 second, peeps. Make sure that I get this over here. There we go. So our covalents are as a result of sharing the electrons, right? So now this comes from the fact that certain atoms become more stable when they actually share their electrons to kind of cover that octet rule that you learn in Gen Chem and that valence level of electrons, so the outer shell of them. So let me change that up. So those are for stability. And then let me add a little bit more to that. So a couple of properties, obviously, as these result as the loss of and gain of electrons. So these are all electric, right? And then they dissociate in water. Whereas our covalents, in this case, which happen to be very neutral, fairly strong in terms of their nature, so they hold together very, very well, and they do not dissociate in water. Right? So those are the big properties that you want to know from those. And then our last one, this is probably the most difficult to kind of explain, simply because it's not as just saying, oh, it's electrons. This one is, in this case, a very weak force as a result of partial charges. For those of you who remember your good old G-Chem, that was called a dipole moment. Not that we need to know that. That's not our stuff, right? But some of our substances, whether covalent or ionic, so this applies to both, display these kind of mini little charges that end up looking like weak versions of ionic exchanges. And so this also results in the attraction of substances due to these charges. However, the biggest thing that we want to know about this is the fact that these act by mass number. In other words, the fact that even though we are calling it a weak force, it literally is probably the thing that is holding us together right now. As humans, as animals, as a planet, hydrogen bonds happen to be all about numbers. So the more you have, the stronger it gets. So it's all a matter of strength in numbers, if you want to think about it that way. So it's the one that holds our bones, our skin, all our proteins, and everything else. So that gets to be talked about in the next set of topics. But hydrogen bonds happen to be kind of this in between both ionic and covalent, that ends up being a fairly powerful force when in the right amount of quantity and mass number. This is all about quantity in this case.
Professor, I have a question.
Yeah, bring it on.
So when it comes to hydrogen bonds, they don't share anything. They don't even touch each other. They're just right next to each
Correct.
other.
So very similar to our ionic versions, right? These are electrostatic attractions. So it's attractions of those positive and negatives, just like you would see in good old GChem, like sodium chloride or something like that. That's just at a much weaker level. So they're tiny charges. They're little baby charges that are kind of pulling each other closer together. But when you get tons of them, and I do mean tons, we're talking about millions, billions, trillions of these coming together, then we get a very strong overall force. And if you looked at or if you heard me talk about in the lecture, the example that I always give for this, because it just kind of makes it easier to kind of explain, is the concept of Velcro, right? The reason why behind that is if you've ever looked at Velcro, you all trust it to hold your clothes on you. Don't freak out that it's going to fall off of you. But yeah, Velcro is extremely weak. If you look at it, it's just a bunch of tiny little weird J plastic thingies, and they all break off very fast. But if you put several thousand, hundreds of thousands, or millions of them, it holds your shoes on, it holds your clothing on, puts your backpacks on, kind of thing. So it's a matter of mass. It's a matter of quantity. So the more you have, the stronger the hydrogen bonds become. But believe it or not, the individual charges are very, very weak and tiny. All right. What else, peeps? This is as much as we kind of want to go with our bonds level, right? And so as long as you know a couple of examples here and there, you should be good to go too.
Would that be like the difference between like intermolecular and intramolecular?
Excellent question. I love the fact that you brought it up. So let's try it here. I was going to try and doodle it, but I'm probably going to screw this up. So let me draw over it. Let me just use PowerPoint for my win in this case. So let me look for this guy. There it is. I'm going to insert another little doodle. It's going to block everything off. Don't freak out. Hang on. Let's take these guys and do it over here. Oh man, didn't work. There it is. So I'm going to cover over these. They're not going to disappear. They'll come back, promise. Just need to format the shape. Nope, need to format the color. And let's do this. Like that. So you should be able to see it kind of blending in the blue. And let's try the other one. Okay, so there's two differences here. So let me just change this color to, I don't know, green or something like that. There. Hopefully you guys can tell the differences between the two colors in there. And so that question that you asked, that intra versus intra, it's a little bit of good old Latin training for medical terminology, right? So intra meaning between and intra meaning inside. So both the ionic and the covalent ones, let me add to this, let me add my text, happen to be what we call intramolecular bonds. So let me put this off to the side over here. There we go. Simply because they're, again, taking place inside the molecules themselves. So if you pick, I don't know, some random molecule, a little sugar molecule or fat or something like that, it's inside of it. Whereas hydrogen bonds whoops, didn't mean to do that, in this case, are referred to as intermolecular bonds. Let me move that to the side too. There we go. simply because they're not occurring inside each of the molecules, they're occurring between the molecules themselves. I'm going to try and draw this again, so for the sake of my horrible example, do this guy. Don't judge me. Oops, moved too far. Erase that. So let's pretend that that's your little molecule right there. It's the blue block. And so what I mean by intra, I'm so sorry, is, let me throw some arrows in here. The stuff is going on inside of it. So I'm looking for some arrows to draw over here, sorry. So let's throw, here's a little arrow, throw that guy in there. And then the stuff, the attraction forces that are going inside of it are happening within it. Whereas, in this case, this guy, let me make a little copy. For an intermolecular bond, I'm gonna make this a little bit smaller. It's occurring between two separate substances in this case, and so they're attracting each other. So let me insert this guy too. Whoops, ignore that. So let's make it a little bit easier. It's not what I meant to do. Technical difficulties, people. I'm trying to do this on a screen really far away from me. There it goes. So this guy is taking place in between them. There we go. See, I'm trying to draw this all as we go. So what I mean by this is that for one example, the intermolecular bonds are occurring within these guys. So let me get this guy going over here. You'll see that this is a separate molecule. So let me get my pen going on over here. Now this is one molecule over here interacting with another molecule over here, or substance. And so that's between them, that's inter, two separate molecules in this case, or more, right? Whereas the intra version of that, let's go to the blue one, let me switch my colors. Here, it's just one single molecule that we're seeing in here, and the stuff is going inside of it. So this is what we call intra version of that. So hopefully that brings a little bit more clarification behind that, and that helps out everybody. Does that work? Everybody got that? Differences between inter and intra. Thanks, Pete.
Yeah.
My half a thumb over there with people. All right, what else? What else do we have? Anybody else? Any other fun questions? I understand, like right now the topics are not that crazy, so some of this stuff should be straightforward, should be very, very kind of direct information, nothing that is taking you out of the ordinary, but you know, leaving things that are unclear or something in the review guide or something like that, talk to me.
I have a question about the tutoring lab. Do they help with our lab reports, or should we not even go to them concerning that?
All right, so first of all, one, remember we're being recorded, but not part of the topic, and that's what I mean by that, is that I'll keep it short and sweet. Yes, you should always go to tutoring regardless.
Okay.
That will always be my default answer, no matter what. But keep in mind that normally our tutors are coming from my class. So these are typically people that have taken my course, got an A, and went in there. Right now, I don't know who's working there, so I'm unaware of who's there at that time. So if you guys want to go investigate and find out what's going on, definitely, you should go regardless. The only reason why I say that is because sometimes just a different version of how to teach the material works for you. Maybe
Okay.
my version is a little weird, maybe not as straightforward as you need it to be, and they do a better job. Second of all, it's personal most of the time, so that means they can just kind of really focus on what your needs are. So yes, I'll always encourage the tutoring. It's even in my syllabus of saying you should be going regardless. But at this time, I don't know who's there, so I don't want to make just kind of some big overarching statement saying, oh yeah, that person is the best. I have no idea at this point in time.
Okay, thank you.
Good stuff, people, good stuff. What else? Anybody else have any trouble? Any weird things, lecture-wise maybe?
I believe Teresa asked about carbon bonds.
Yeah, what you like to ask about carbon bonds? Tell me. What can I expand upon that? And like I said, people too, as you're coming up with other questions or answers, just type it up or anything like that. If you don't want to throw your voice out there or anything like that, not a problem. And I think while Khalila's looking to ask a little bit more behind that, and he said, it looks like you raised your hand and it went away. Do you have a question too?
Yes.
What's up?
Yeah, I have a question. In the textbook, there are like bunch of exercises. So should I, go through those as well for the test?
Okay,
Like
so
the questions
perfect
at the
question.
end of.
So that's something, that was a weird sound. And he said yes, and so this applies to all of you, especially because one, you probably spent a boatload of money on that book, right? So use it. And so now what I've told you, especially from day one when we met, is that I only hold you responsible for the things I talk about, right? So if I never mentioned it, if it's not in my recording, if it's not in my handout or my note, you don't have to know it. It won't appear on the exams, it won't appear on any homework or anything like that, right? That doesn't mean you shouldn't be looking at it, right? And so your textbook, in the same order that that stuff is, I take those images on purpose because I want you to be familiar with the material. So the pictures that I use, the tables that I use, and even the order, the kind of the sequence that I use, the chapters follow the textbook too. So yes, you should be using the textbook regardless. Now, at the end, they always have their cool little sets of practice questions and everything else out. Yes, the reason why I recommend that, even though those are not my style of asking questions, mind you, I don't ask questions like that, is because they're good practice. This is they kind of force you to kind of go back into the book and review a little bit more. And they also cover some of the materials a little more in depth sometimes that I don't get to spend too much time on. So you should definitely use those, even as your own little self quizzes to prepare your own like note cards and things like that. Definitely go after them. Now, again, mind you, I will not hold you responsible for those if I didn't cover them during my lecture. So that's kind of where that difference lies. So I'll never discourage you from going in there or from accessing another textbook and practicing those things out. Definitely go and do that. And typically, most of the ones that are at the end of the textbook are pretty good. So they kind of covers the same material that I think are important too. I just have a tendency of removing some of the ones that I don't think so, and so I throw those off to the side. But you practicing them, please, by all means, go in there and use that book. Again, expensive little piece of paper that you should definitely be taking advantage of. So let's see. Chelsea just kind of left us a little recommendation for those of you who didn't see it. I do not know who Daniel is, unfortunately. But if he's good and if he's working for you guys, go for it. Go talk to them. So I haven't had a chance to meet them, unfortunately. Usually they come to our class live and they'll present themselves and say, hi, we're the tutors and that kind of thing. Clearly, we don't have a classroom for that right now, right? But they usually kind of bring it on. They're pretty good stuff. Let's see. Let's see.
I have a question. Are you gonna put any of on the test about the monomers and polymers?
Definitely yes. So
Okay.
hang on for that. I'll expand upon it a little bit more. But I had a little question over here on talking about the microscope question. And so let me expand upon that really quick. I'm just switching stuff around. So regarding the microscope, yes, it is still part of the exam, but no, I'm not going to ask you about the types of that because we get to do that in the lab. So in terms of microscopy, oops. So for the microscopy portion of this is, I don't need you to know, you don't need to know types. That's for the lab. But you should know the properties of the scope. Can I spell properties? Hang on.
No, it's wrong.
And there it goes. So for that, in this case, you should be knowing things like what refraction is, right? What wavelength is. For example, this idea, what we talk about, of course I misspelled that too. Same concept of parfocality that we talked about also in the lab. So that's also important to know, right? And more than anything else, probably one of the biggest things is the magnification. And for that, what I'm talking about, it's specifically resolution. Meaning not only its definition, but also limitations. For example, your standard scopes, even the ones we're going to be using it in the lab this week, believe it or not, is that, for example, our light and compound scopes have this resolution limit called resolving power of about 200 microns. Meaning that they cannot separate things out that are smaller than that. It's too small, we won't be able to see very much. And then we go into the field of electron microscopes. And so for that, you get the two big types that we do want to know a little bit about are your scanning electron microscope and your transmission electron microscope, your TEM in this case. And so for that, that resolution is about 10 microns. Oops, didn't mean to put that line there. And then this guy is 0.5 microns in this case. Well, what that means is what we call 5 angstroms. Basically the size of atoms. That's what we get to see that. And that's really how in-depth do we want to know the microscope for now, because the rest of it is really practice, and we do that in the lab. And so what I mentioned in the lecture during the YouTube channel or live is just saying, understand these definitions of what refraction is, which is bending of light, that how our scopes observe things is through wavelengths. The bigger the things are, the smaller things are, we can see or not see them. And then magnification in terms of being able to resolve things, to be able to tell two things as being apart or not. That's really the level of microscopy that I need you to know. No more than that. So hopefully that helps that a little bit.
I just remembered a lab question. Could you answer
Yeah,
it?
bring it on. Even though not part of the exam, so keep that in mind and establishing that, yes, bring it on.
Okay, so you know how we had to measure in lab 4, measure the E? Would it be like around, like you said, the resolving power when we were measuring the E, would it be like 200 when we measure it?
That would be its limitation, but you guys didn't get that far, believe it or not. You guys didn't go down to that 200 micron level. For the letter E, you went as far as the yellow objective, which was, sorry, the blue objective, which was our 400 external magnification.
Yes.
And the resolving power for that guy happens to be about 450 microns. So it's a little bit bigger than that size. That's its limit. You can't see anything smaller than the 450 microns accurately. And then if you look at the supplement, it kind of gives you those tables right there. Let me see if we can pop this guy up really quick. It takes me a while to load up that file since it's fairly massive. Here, let me move on to the other question, which was, okay, this thing is not behaving. On the OCHEM bit, but before I answer that, since you had questions about the drawing portion, I'm just looking for that over here so I can show it to you guys too. There it is. So it should be on slide 93 of your supplement. So it shows you roughly what the resolving power is of each. So let me kind of show that really quick. So there's this guy. So that's slide 93. And it shows you right there when you're drawing your letter E or whatever it is, you guys made it to this blue one up here. So let me just switch my pointer over here. So this blue one right here, that was our blue objective. That's our 40x objective that magnifies a total of 400 times total magnification. And like I said, its field of view, its resolving power, its ability to discern things is about 500 microns. It's actually about 450, but 500 is an easy number to work with. That's as good as you can tell things out. Anything smaller than this, either it's kind of blurry or it's not accurate when you're trying to do that. So we do have the oil immersion version, which is the bottom one, but that we did it for the bacteria, and that's what we're going to start using this week. So that's where that guy comes from. Hopefully that helps a little bit with that question. Does that clarify that?
Yes, thank you.
All right, so now, oops, I stopped my little screen sharing. Not sure what happened. Let me try this again. There it is. There we go. One definitely piece that you need to know about this is your ability to understand macromolecules more than anything else. So let me get over here into this bit. So the formation of macromolecules. And the reason behind it, one, not only is part of this test, but we literally use this the entire semester. We talk about the building of materials for life, basically. So even though that's not quite the part of this topic, the importance behind this for us, so again, not in this test, is to build materials for life. That's why we talk about macromolecules, right? And so we mention this in the context of what are the macromolecules you need to know. So macromolecules, wow, in this case, are substances that are assembled in repetitive components. Not that I'm going to ask you that definition, believe it or not. So that means that there's a pattern. And so there's the types that we got to cover in there were your carbs, your fats, right? Your proteins, and your nucleic acids. Whoops, that's NSA, that's a whole different thing. Right? So you were supposed to understand what those are and their properties. But more than anything else was also understanding how to build them, right? Again, there's a pattern. So how to build them. Not sure why my little A got autocorrected over here. And so this is based on the chemical reactions that we were supposed to know from this topic. And so for that, we have two types. And so for them, we had our to build polymers and to break them apart. Those are the two main reactions that we were going to learn. And so each one of them has its own unique name. So for the building one, it's called dehydration synthesis. Whereas for the breaking one, whoops, it's called hydrolysis. Oops, there it goes. Right, and so the idea here is what does each one of them do? And so in the lecture, it kind of goes a little more detail on how those reactions actually work. But the one part that I never get to have fun with unless I do it live is to talk for my rabid fandom of Lego pieces. Not only because they're really cool to build stuff with, but also because they're deadly if you step on them, right? So they have this dual nature to Legos. But the idea is to kind of mention this idea of repetitive pieces. And so here, let's try this. Remember, macromolecules are built of things that are repetitive. And so Legos make a really, really good example of having things that are just kind of fairly repetitive. And so we end up calling the individual pieces behind them, we end up calling these monomers, right? So one single piece, one single unit. So let me get in there, shape. Let's go behind that guy. Oops, that didn't work out as well as I thought it was going to be. There it goes, right? That's called a monomer. That didn't work out very well either. Let's try this again. There it goes. Man, this is the finesse that I don't have. There we go. So each one of them is one component. And so when you put enough of them together, you assemble a pattern. And so the idea is to take these individual monomers and build them into polymers. So let me kind of take one of these and just kind of demonstrate that. Because the idea is by adding them, is that we can build something together. That's the idea. That's what we're trying to do. Is that we can take these guys and build something cool out of it. And so this is what we call a polymer. Right? And so the polymers you get to know right now were just your carbohydrates, your lipids, your proteins, and nucleic acids, because for topic C and D and pretty much everything else after that, we'll be talking about those four. They're all the main concepts of teaching biology in general and also micro. So right now it's all about knowing the reactions that build them. So the ones that kind of build the monomers into these polymers. So let me see if we can take this guy. I'm going to try and do these with colors, just so you know. Don't judge me here. So if you want to build the polymers, so you want to go from the units, sorry, so the subunits to the larger units, that's called dehydration synthesis, simply because when that process assembles, you lose a little bit of water, right? But when you want to break these things into smaller pieces, like for example, what we do during digestion, so that we can get nutrients out of them, we can break those apart. And so breaking those apart is through a reaction called hydrolysis. Even the word lysis tells you that you're breaking things. It's in the opposite direction. So you go this way, from the bigger piece to the smaller pieces again. And so that's really what we're taking from that final piece of topic B. It's the breaking down or building of these polymers. And what I mean by that is breaking down or building of carbs or breaking down or building of fats, that kind of thing. And the two reactions associated with them. And that's part one of that story. The second part, which goes at the end, the very last piece we cover in topic B, are those properties of carbohydrates, lipids, proteins, and nucleic acids. And so let me add to that just to make sure I'm not a little crazy over here. make sure you understand the properties and the overall structures. You don't get to draw them, but you should be able to identify them because they will appear in the exam, I promise. Does that kind of help too? Does that make any sense to y'all?
Yeah, it does. Thank you.
You know, the only reason why I'm holding this is because I need thumbs, people. Just killing me. Like, I need to see my wall of thumbs. That's what I want. That's like cocaine for me. Understand that. I shouldn't have said that. Seriously. Okay. What else can we help you out? What other questions? What's unclear? What can I help with? And once I get this video kind of recorded and set up, I'll throw it on the YouTube channel, kind of on the hidden side. And then also, remember, we have another session tonight. Don't forget that too. Edith, so for that, most of it is. There's a couple of questions in there that are kind of short answer because I just can't, on general principle, give the entire exam away. You know, I have to just give you a little bit of a challenge. So there's a couple of them that you're going to be entering and typing in like 2 or 3 words, and that's about it. Everything else should be multiple choice at this time. Anything else? You're all too quiet for me, people.
Professor, will the test be fill in the blank? Like we have to write like statements and stuff?
No, again, like I said, it's going to be maybe 1 or 2 words at best. So let's call it short term. That's usually the easiest words I like to use for the exam. And then the rest will be multiple choice. That's it. No long statements, no stories, no essays, nothing like that. So it's too difficult to grade those through Canvas. So if we were live, I'd probably change that a little bit. But no, for this, the majority will have multiple choice versions, and then a couple of them will be short-term answers.
Will we be able to see the score right after, or a human
Yes.
has to?
The score will be
Right.
immediate with one exception. Any of the short-term ones usually require me to go in there and grade those. So your score probably will be off by 1 or 2 or something like that. And usually I go through them within the night or 24 hours, and then you can see those. But yes, you will be able to see your score immediately once you're done with all the regular or gradable questions. Yes, you will be able to do that.
And it's timed as well, right?
Yes. So now I want you to understand what I mean by this is obviously just like a lecture exam in real life, you know, you'd sit down, I hand you pieces of paper, you'd fill it out, and you'd have that entire hour to work on it, but you'd only have that 1 hour, right? So since this is a relatively short exam, I honestly don't anticipate anybody taking more than 20, 30 minutes for it. But you should take the whole hour, you know, review it, go through it several times to make sure you maximize everything. Take it slow, have a decent pace behind it. You will literally have 2 to 3 minutes per question, and reminding you that you can't go back on them because you can't make corrections on these guys. You really kind of want to cover them in detail, right? But again, it's only for that hour. So if you want to start it tomorrow at 1 a.m., at 2 a.m., that's it. That's where it ends. Or if you want to start on Tuesday at 9 p.m., at 10 p.m., it's done. It will close down. It's only open for that 1 hour that you choose to open it. So it's entirely up to you when you decide to do it. If you feel ready for it right now, start it in a couple of hours, you're good to go. If you still want to have some time to review, want to go get the lab over first, for example, for my Monday people, and you want to meet me for office hours on Tuesday morning or something like that, that's perfectly fine too. So you decide when you take that 1 hour to take that exam. And thanks, Violet. That's kind of what I'm meant to do, right? It's, especially during these crazy times, it's really difficult to handle these classes, especially micro more than anything else. I can envision like an English class being a little bit easier than doing this. Not that I'm downplaying the English class, but so micro can have its challenges. So having this kind of distance relation is a little challenging. So that's why I do this. So that's why I want you guys to be here. And so truly take advantage of this. go online, set up office hours, whatever it is, and I'm happy to help. If you have the chance to be here this evening too, I think it's at 6, I remember that, bring it on. I'll be there too, okay? So unless you have any cool stuff to say, go have some lunch, go enjoy some food, and I'll be here anytime you need me.
Thank you.
Anytime, guys, anytime.
Thank you.
Thank you, Professor.
Thank
Take care.
you.
Thank you, Professor.
Oh, Professor, you're gonna be uploading this like
Yes,
right after.
so it takes about 2 to 3 hours to do that fully, but yeah, it will definitely upload.
It'll be on YouTube, right?
Yeah.
Awesome.
I'll
Thank
send you
you.
guys an announcement for it too.
Thank you, Professor.
Of course, Anissa, not a problem. Thank you.
I had a question, but it's not from, like, it's not about microbiology though.
Okay. Well, then let me stop the recording. That way it doesn't get
Okay.
added to that. But yes.
Okay.